You've probably been there. You ask an AI chatbot a pretty simple question, and it gives you this incredibly confident, well-written, and completely wrong answer. It's kind of funny, but also a little unsettling. Well, what if I told you that AI making things up isn't just a temporary glitch that's going to be fixed? What if it's a permanent, unchangeable part of the technology itself? Let's get into it.
So yeah, this is the big question, right? Why do these unbelievably powerful tools sometimes just invent things? They'll make up facts, cite sources that don't exist, you name it. To most of us, it just feels like a bug, something the developers should be able to track down and squash.
So let's start right there with that weird contradiction. We have these models that can write incredible poetry, that can code complex software, but then they stumble over some really basic facts. This whole phenomenon has a specific name, and it's really the key to our whole conversation today.
Yep, the official term is hallucination. And it's important to know this isn't just a simple mistake. A hallucination is when the AI creates something that sounds totally plausible. The grammar is perfect, the tone is confident, but the information itself is just wrong or complete nonsense. It's basically a confident fabrication. And our first instinct, naturally, is to treat it like any other software bug. We figure, okay, with more data, with bigger and better models, with smarter code, we'll eventually engineer this problem away. But what if that whole assumption is just wrong from the get-go? And this is where things get really interesting, because it brings us to the heart of a pretty groundbreaking research paper. Instead of just trying to patch the problem, these researchers decided to ask a much, much deeper question. And there it is. Not can we reduce it or manage it, but can we get rid of it completely? Is it even possible to build a large language model that is 100% guaranteed to never, ever hallucinate?
Now, what's so cool about this is how they figured it out. They didn't just run a bunch of tests on GPT-4 or Claude. No, they used a formal mathematical proof, pure logic, to come to an answer that is absolutely definitive.
The proof itself is based on a classic idea from computer science, but don't worry, you don't need a math degree for this. The best way to think about it is as an unbeatable logic puzzle. It's a method for creating a perfect, inescapable trap for any AI.
So, how do you build this trap? It's a really clever three-step thought experiment. First, just imagine you could make a list of every single AI that has ever existed or could ever exist. Next, imagine a list of every possible question you could ever ask. Now let's pair them up. The first AI on the list gets the first question, the second AI gets the second question, and so on. But here's the final crucial step. We create a special answer key, a ground truth, that is specifically designed to contradict whatever answer each AI gives to its paired question.
Okay, and this table here is the aha moment. It shows exactly how the trap works. Each row is an AI. Each column is a question. The proof zooms in on the diagonal. AI1's answer to question 1, AI2's answer to question 2, and so on. Then you create this trap ground truth. And the rule for this ground truth is simple. The real answer to question 1 is the opposite of whatever AI1 said. The real answer to question 2 is the opposite of what AI2 said. You just go all the way down the diagonal, creating an answer key that's designed to make each AI wrong on that one specific question.
And the result is, well, it's a perfect trap. By the very logic of how we built this scenario, any AI you pick from that infinite list is guaranteed to be wrong about the ground truth for at least one question, specifically the one we pick for it on the diagonal. It's absolutely inescapable. Hallucination isn't just possible, it's logically baked into the system.
So, this completely flips the script on how we think about this problem. If it's logically impossible to get rid of, then hallucination isn't some bug we can just patch. It's an inherent feature of what these things are. The researchers' conclusion couldn't be more clear, and it's worth reading out loud. They said, hallucination is inevitable for any computable LLM regardless of model architecture, learning algorithms, prompting techniques, or training data. That's pretty definitive. It doesn't matter how you build it, how you train it, or how you talk to it. The limitation is fundamental.
And this means all the usual fixes we think of just won't work to eliminate the problem. You might think, well, just give it more training data. But the proof shows you can always build one of these logic traps. Okay, what about a bigger, more powerful model? Doesn't matter. It's still a computational system that will fall into the same trap. Even trying to fix it with clever prompting is a dead end, because you can't ask an AI to fix a limitation that is literally part of its own nature.
So if we can't get rid of hallucinations, what do we do? Well, the first step is to get smarter about where they're most likely to show up. And it turns out these failures aren't random at all. They're actually pretty predictable.
The researchers pointed to specific kinds of problems that are basically hallucination-prone. These are tasks that are just computationally brutal. Think about things like certain types of logic puzzles, which belong to a class of problems that are so hard, we're pretty sure no computer could ever solve them quickly. And for others, like determining if one logical statement proves another, it's even deeper. Some of these are undecidable, which is a fancy way of saying it's been mathematically proven that no computer program can ever exist that can solve it perfectly every time.
And that's really the key thing to understand here. When an AI fails at one of these tasks, it's not a sign that the AI is dumb. It's a reflection of the deep mathematical difficulty of the problem itself. Some questions are just fundamentally rigged against this type of AI.
So, what does this all mean for us, the people actually using this stuff? This research strongly suggests that the way forward isn't just about building a smarter AI, it's about us becoming smarter users of AI.
So what should we take away from all this? First, and most importantly, we just have to accept that these tools will make things up. Period. That means for anything truly critical, we're talking medical advice, financial decisions, legal stuff, human oversight isn't just a suggestion, it's non-negotiable. Now, things like connecting an AI to a search engine can help, for sure, but they don't solve the core logical problem. The real key to using AI safely is knowing its limits, understanding what it's great at, and knowing where it's guaranteed to fail.
Ultimately, this whole thing forces us to shift our goal. We're not trying to build a perfect, all-knowing oracle that never makes a mistake. What we're actually building is an incredibly powerful tool. And just like any other powerful tool, its value and its safety come down entirely to how wisely we choose to use it. And this really leaves us with a huge, critical question to think about. If we know for a fact that an AI making a mistake isn't just a possibility, but an inevitability, where do we draw the line? What are the critical parts of our world where we should maybe never hand over the final say? That's a conversation we all need to start having.